4. Can you believe we're already on rule number 4 of 5? 80% of the way through our 5 exponent rules. If you're keeping track of when your next test is going to be, it's after PO 15. We'll do 13 today, 14 tomorrow. 15 will probably be a double feature next week, Monday, Tuesday. Review Wednesday. Plan on your test being next Thursday, so a week from today. That's kind of the trajectory that we're on. If we get off of that, we can move the test to Friday, give us a wiggle room day, but plan on Thursday next week for the test. And we are now, we are now at the point of talking about negative powers. Okay, it may have been a surprise to some of you that an exponent could be 0. It might even be more of a surprise, even though we did talk about it back in CO10, that exponents can also be negative, and exactly what that means. Okay, and we're going to look at patterns, because a lot of, like we talked about before, algebra is all about patterns. A lot can be discovered by looking at what we know and projecting that out to what we don't know. Okay? So we're going to start and try and make your start up top. Don't write big because we have to fill this out here. But we're going to start with 2 cubed. Okay? In expanded form, what is 2 cubed?
2 times 2 times 2.
2 times 2 times 2, and that is equal to 8. Right? 2 times 2 times 2 equals 8. There are 3 2's, all they multiply together, that equals 8. We know that, right?
Yeah.
Now, if we start the pattern of decreasing our exponent by 1 and looking at 2 squared, what is 2 squared in expanded form?
2 times 2.
2 times 2, which equals what?
4.
Which equals 4. Okay? If we decrease our exponent by 1 again, and we're looking at 2 to the first power, 2 to the first power in expanded form is just 2, which obviously equals 2. So, looking at already what we have here, what patterns are you seeing? Algebraically, again, starting with what we know, what patterns are you seeing? Addie?
Every time you go, every time you take a 2 away from the exponent, or 1 away from the exponent, it goes down and what it equals.
Okay, and how does it go down? Well, not really decreased by 2, because that kind of means it would be subtracting 2 each time.
It gets divided by a half.
Yeah, if we don't multiply by that extra 2, it gets cut in half each time here, right? Half of 8 is 4, half of 4 is 2. If we continue with 0 powers, which we just talked about, there really is no expanded form for a 0 power. Does our rule hold? What is 2 to the 0 power equal? Claire? What is 2 to the 0 power equal? 1. Does our pattern hold?
Yeah.
Yes. Right? So now, we've got this pattern developing. Here's where we interpret what's coming next. If we decrease our power again by 1, it's going to be 2 to the negative first power. Now, we'll talk about expanded form in just a little bit. But what is that going to equal?
0.
Madden?
0.5.
0.5 or
1/2.
1/2. Because if we continue the pattern of what's going on here, where every time we decrease our exponent by 1, our solution gets cut in half, half of 1 is a half. Let's look at 2 to the negative second power. Let's decrease our exponent again by 1. We'll cover expanded form in just a little bit. What value is that going to have? Follow the pattern. Will, 1/4. Half of a half is a 4th. Okay? Let's do it one more time. Hopefully you still have room on your page. I told you to write a little bit small. If we decrease our power again by 1 to go to 2 to the negative third, we'll cover expanded form in a bit.
Is it 2 to the...
But what is that going to equal as far as value, Kyle? 1/8. Okay? Now,
Oh, I see what's going on.
take a look. I heard someone say that. I see what's going on here. Let's all take a look at what's going on. Notice the connection between 2 cubed, which was 8, and 2 to the negative third, which is 1/8. 2 squared is 4. 2 to the negative second power is 1/4. 2 to the first is 2, to the negative first is 1/2. Essentially, what are you seeing is going on here when you've got a negative power? Claire?
You're using, like, if it was like positive, you're using the number with the outcome like as a denominator.
Right, okay? Our outcome for our exponent is the same in that like 2 cubed 2 to the negative third, we get 8 either time. But where that 8 is, that's what's going on. Okay, boys? Where that 8 is, that's what's going on here. Expanded form of 2 to the negative first is 1 over 2, which equals 1/2. Just like 2 to the positive first was just 2, which equals 2. Nothing really special about that. Okay? 2 to the negative second in expanded form is 1 over 2 times 2, which is kind of the same as 2 squared, 2 times 2, but instead of the numerator, it's in the denominator, and that's where you get the 1/4 from there. 2 to the negative third, instead of 2 times 2 times 2, it's going to be
2 times 2 times 2.
in the denominator. 1 over 2 times 2 times 2.
Mind blowing.
Okay? So the first thing to notice here is that with negative powers, do we have any negative values over here? No. A negative exponent does not make the base negative. Okay? A negative exponent does not make a base negative. What a negative exponent does is it tells you that it's in a different part of the fraction. Okay? To the positive third, that 8 is in the numerator. To the negative third, that 8 is in the denominator. That's what's going on here. Okay? How we doing?
Not very good.
Already it's horrible. How can I clarify? What about this chart isn't making sense?
Am I right?
Your writing line. Okay, so let's capture this so that I can put it on my fridge at home and my nice looking chart there. And let's talk about what the rule is. Okay. Coefficients. This rule and negative exponents here are all about moving things. You can think about if a base is a negative power, that means it's not happy where it's at. So we need to move it to the other part of the fraction. The coefficients stay put. Okay, the coefficients stay right where they are. They do not move because, as in every other rule, are the coefficients affected by the power?
No.
No. Okay, so they stay right where they're at. Exponents move to the other part of the fraction and they become positive. Okay? When you move an exponent to the other part of the fraction, it becomes positive because you moved it. A negative power means it's not happy where it's at. If a negative exponent is in the numerator, it's not happy there. So move it to the denominator. Now it's happy. Positive. If you have a negative exponent in the denominator, it's not happy there. Move it to the numerator. Now it becomes positive. Now it's happy again.
Gotta please your
Right?
negatives.
Yes, we have to please the terms. The base stays the same, but follows the exponent. So the base gets moved as well, but it doesn't change. The base isn't negative, right? The exponent's negative. The base doesn't change, it doesn't become negative or switch to positive, right? There's no change there, only the exponent does. The exponent is what is negative, the base is moved with it, but the base doesn't change. Lucas?
How do you work with a negative number to a negative power?
It depends on if that negative number is in parentheses or not. So like if you had something negative 2 to the negative 4th power, is that kind of what you're asking? Okay. Is that negative sign part of the base?
No.
No. So what you'd move is this part right here, right? That would move to the denominator of a fraction, and you'd be left in the numerator with a -1. So it'd be negative, that negative sign wouldn't move. It's technically a coefficient, not part of the base, so that would stay. But the exponent would move the other part of the fraction and become positive. Okay? So, here's something to practice. 7n to the -3rd. What's being moved here? 7n to the -3rd. What's being moved? N to the -3rd. Why not the 7?
Because
Because of the coefficient. The coefficient stays put. Okay? Where does it get moved to? The bottom. Now, this is not written as a fraction, and the reason why is because there's nothing in the denominator. We can make it a fraction by putting it over 1, okay? But this n to the -3rd gets moved down to the denominator. The 7 stays put, the 7's still up top. The base doesn't change, it's still n. The exponent becomes positive. So 7n to the -3rd is the same thing as 7 over n to the +3rd. The 7 didn't change, it did not move, the n moved, wasn't changed, the base stays the same. The -3 becomes a positive power because now it's happy. It wasn't happy in the numerator, we moved it, and now it is. Okay?
Yeah.
Ah, simple enough, right? 12x to the -9th y, what is being moved? What is not happy? Just the x to the -9th. The 12 is a coefficient. Why isn't the y moved? What's the exponent on the y?
None, it's 1.
It's a positive 1. Okay? It's not written, but it's a positive 1. If an exponent's positive, it's happy where it's at. So the 12 stays put in the numerator. The y stays put in the numerator. And the x to the now positive 9th is in the denominator.
I get
Okay?
it.
Next one, what's getting moved? Henry?
Is it the 3?
Not the 3. The 3 is a coefficient, the 3 stays put. It is only the base that gets moved, the base with a negative power. And since that negative exponent's in the denominator, Henry, where's it moving to?
The numerator?
The only other option, it's going up top. Okay? The 2, that's already up there, doesn't change, right? That's just a 2. The 3, which was a coefficient, doesn't change, but now in our numerator, we also have that n to now the positive 5th.
Now the 3's all lonely.
The 3 is lonely, but it's an introvert.
It's not.
It's an introvert, so it's okay.
But
3 is the loneliest.
The next one! What's getting moved?
the -3.
Jude!
The t and the -3 and
Where's it going, Jude?
to the denominator.
It's going down. What else is getting moved?
The c and the -5.
Where's it going?
To the numerator.
It's going up top. Okay? It's okay to have multiple negative exponents in an expression. Okay? You just move whatever you have to. T to the -3rd is not happening in the numerator. So down it goes, becomes t to the +3rd. C to the -10th is not happy in the denominator. So up it goes, becomes c to the +10th. Okay? The base moves, the power moves, the power becomes positive. How are we doing?
Great. Good.
Questions on this?
No.
Okay. The second row here. 1 over h to the -1st. I'm going to just pound this into the ground. What gets moved?
The H -1.
Where does it go? Up top. Okay? There's already a 1 up there. We now add an h to the positive first. And what's left in our denominator? A 1. Do we have to have all those 1s there?
No.
No, this is like the ultimate hidden math expression, right? If a coefficient's 1, we don't have to write it. If an exponent's 1, we don't have to write it. If the denominator's 1, we don't have to write it. This just boils down to just be h.
What did I say?
Okay?
H is so
Now,
lonely
If your exponent's -1, you do have to write it. Right? You do have to write it. If it's +1, you don't. If it's -1, then you do have to put it there. The next one, raise your hand. What gets moved? Maybe someone we haven't heard from yet today. Grayson.
A to the -5th and C to the -1st.
Yup. 18 and B stay up top. 18 stays up top because it's a coefficient. B stays up top because it's got a positive power. In our denominator, we now have A to the +5th and C. If you want to write the positive first, then you can. You don't have to though. But they're both down in the denominator. Next one, Lauren. What gets moved?
The Y11.
No, the y to 11 stays put because the power is positive. It's happy there.
Why?
We want to get rid of the negativity.
So the -7 goes up top?
The -7 goes up top. It's not happy in the denominator. We want to move it up. What else moves? Elsa.
-9.
Yeah, the b to the -9 is not happy in the numerator. We want to move it down. The a squared, positive power, we're good. The n, now to the +7th, joins it. Okay? The b to the -9th gets moved down, becomes b to the +9th. And the y to the 11th, which is already there, stays there. And we can't combine any of this stuff because none of the bases are the same. So we leave it just like it is. Olivia, your hand was up?
Huh? I have the answer to the next one.
Yes. Olivia, what gets moved and where does it go?
As -2. And it goes to the denominator.
Yeah, so 4y squared is in the numerator, n squared is in the denominator, okay? Even when something isn't written as a fraction, it can be a fraction if you put it over 1. So the denominator always exists, whether it's 1 or not. Questions on this row at all? Okay, the next page. It says, this seems like a good time to review the other rules we've already covered. Simplify each expression using the rules we discussed so far. Only write it in expanded form if you must. These are not meant to be written in expanded form. I want you to be using the rules. Now, again, each rule has its little helpful hints for you. I'm going to make this page smaller so I can fit it all on one screen here. We'll go like that. Fit all of them? That fits all of them. That top row, you literally see multiplication symbols. What rule does that tell you you are using?
CO10?
Yeah, multiplying by the same base. This all goes back to CO10. If you need to review, that first row is all CO10. You see the multiplication symbol, it's multiplying by the same base. Second row, they're all fractions. What operation is a fraction? Division. So what are we doing? Dividing by the same base. CO11. The next one, you got a whole bunch of 0 exponents in there. Guess what rule we're using? CO12. 0 exponents. The last row, you've got a whole bunch of negativity. CO13, negative powers, right? These rules don't hide themselves. What you see in the expression is the rule that you're going to need to use to simplify it. Okay? This page is going to be due tomorrow. You've got about 5 minutes to work on it now. Again, only write it in expanded form if you have to. The goal is to know, recognize what rule is being used, and then know how to use the rule. That is the goal here. Okay? Questions, comments, concerns, complaints, compliments, congratulations, criticisms on CO13 or any of this page. Addie?
I don't know if you mentioned this or not, but our calculators allowed.
Calculators are allowed, yes. I don't know how helpful they're going to be, but they are allowed, yes. Also, Khan Academy is due tonight. If you haven't done that, don't forget about that. You have until 11:59 p.m. to get that finished.
So I can get it done at 11.
11, yep, that's fine. Olivia.
Is that a challenge?
Folks, hold on. Hey, Grayson, please have a seat. Lately, I've not stopped recording, Gabe. There's some people with hands up, yeah.
For Khan, do we have to get 100% on each of the assignments?
If you want 100% in the grade book, you need 100% on the assignment. Basically, whatever score you get on the assignment is the score that goes into Black Line. So if you want 100%, do it to get 100%. Lucas,
I tried logging in Khan yesterday and it says it won't
bring your computer up to me when I'm done recording, please. Babe,
thought I was gonna fail, but now I'm not. Thank you, sir.
Excellent. You are very welcome. Happy to help. Emerson.
When I try to get to Khan Academy, it just levels.
Okay, if you're having trouble getting into Khan Academy, bring your computer up to me and we will troubleshoot together. All right, homework for tomorrow is this page. That's on math.
Don't forget to like and subscribe.